Okay, so we can look at some more example for the technique of solving a quadratic by completing the square. So I'm looking at my third example for this kind of technique here. So once again, my equation here is to solve the quadratic x squared plus 8x minus 20, right? So once again, step number one, always we would like to bring, so my equation x squared plus 8x minus 20 equals 0. I would like to always bring that term to the right side. Okay, and the way to do that, I'm going to add 20 to both sides itself this time because the term itself is a minus 20, so I need to add 20 to both sides. And so what I have here is it's going to reduce to x squared plus 8x equals positive 20. Okay, so now in my next step, once again, my b value is a positive 8. B equals 8. Everybody see that clear here? Solid clear? So my b value is equals 8. So I have to do a little scratch work on the side here. I need the quantity b over 2. I always need the quantity b over 2. And so my b over 2 here is this time it's a positive 8 over 2, right? And that is going to be 4. So 4 here is my quantity b over 2. So now, on the left side, I first need to complete the square on the left side. And the way to do that, first of all, nothing as easy as this. Put for myself a pair of parentheses and put the square here. And what I need to put in here is simply just dx, right? And the value for b over 2. So b over 2 is 4, so I put 4 in here. What is the sign for b over 2? It's a plus sign. So I do a plus like that. So I got x plus 4 all squared. And then on the right side, the 20 is still there. But what I need to do is I'm going to add to it. B over 2 all squared. So b over 2 is a 4, right? But the square of b over 2. So it's going to be 4 all squared. Okay? So now my equation this time would reduce to be, I would have x plus 4 all squared equals 2. Now 4 squared is a 16. Plus with a 20 is a 36, right? So now, at least once again, my next step here of the equation, I have turned that into the equation of the form that where I can use the square root property. The square root property, because I can just simply have a perfect square on the left side and a number on the right side. Okay? So, my next step, using the square root property, I can just have x plus 4 equals plus and minus square root of 36. And once again, square root of 36 is a 6. So I have plus and minus 6. And my equation on the left side, x plus 4. So now, to solve for x now, subtract 4 from both sides. Right? And what I would have here is x equals minus 4 plus or minus 6. And once again, what this plus and minus means right here, what this notation plus and minus means right here is one x value is going to be minus 4 plus 6, and that would be positive 2. The second x value, my second x value here is going to be equals to minus 4 minus 6. So that would give me minus 10. So these are my two solutions to the quadratic equations, x squared plus 8x, x squared plus 8x minus 20 equals 0. Okay? As another example, we can look at another example. And then once again, at some point, if you lose me, you can always have the option to rewind the video tape here, this video here, to learn it again. So now I'm going to look at example 4. Still, we're looking for the complete the square technique. So I want to solve the equation x squared plus 5x minus 6 equals 0. Okay, so my equation x squared plus 5x minus 6 equals 0 right here. The c term is minus 6. I want to bring my c term to the right side. So what I need to do this time, I'm going to have to add 6 to both sides. Okay, and so to do that now, after doing that, I have x squared plus 5x equals 6. Okay. And then once again, at this point here, start looking for my b value. My b value is right here. B is positive 5. Positive 5. Now, once again, I noticed that through my class that some of my students are not having the habit of counting signs together with the number. Please do practice for yourself one more time. Practice for yourself the habit of putting signs together with a number. So here, b equals positive 5. So now, once again, on my little side note here, I have to do b over 2. And so as a quick calculation, b over 2 is 5 over 2. And we should leave that as here as a fraction. Okay? So now, what I'm going to do next is I'm going to have to turn the left side here of the equation here into a perfect square. And the way to do that is just simply, I'm going to write for myself a pair of parentheses with the square outside right here. Okay? And so we have been through 4 examples right here already, and you can see that it's pretty much the same thing, right? And then you can put in here, once again, what goes into this inside the parentheses here, what goes inside it? X, okay? And then what I'm going to put in the value for b over 2. Now the value of b over 2 this time is a fraction 5 over 2, right? A fraction 5 over 2, so I'm putting in that fraction 5 over 2. What is the sign of 5 over 2? Plus sign. Okay, so I have x plus 5 over 2, and that is equals to 6, right? Now on the right side, what I need to do is I need to add to the value 5 over 2, which is the quantity b over 2, right? But then I have to add to the square of that. So 5 over 2 all squared. So now, maybe I'm going to produce one more step. On the left side, x plus 5 over 2 all squared. Okay, and that is equals to 6 plus, now 5 over 2 all squared is the same as 25 over 4. Okay, because you square the top and you square the bottom. So that's why you get 25 over 4. And then once again, if at this point here you got a number, add with a fraction on the right side. If you are weak with adding fraction, you got to practice with this on your own. Okay? And then my calculation here is showing me that I have, this is going to be so that gives me 49 over 4. Okay, on my right side and on my left side is the same thing. X plus 5 over 2 all squared. So now, what is so good about my equation at this step? This step here tells me that I can once again use my square root property, because on the left side I have a perfect square. I have a perfect square on the left side. I have a number, even though it's a fraction, but it's a number on the right side. So now using the square root property, I have x plus 5 over 2 by itself, no square, equals to plus and minus square root of 49 over 4, which is the same as x plus 5 over 2 equals to plus and minus square. That's when you get through the square root, you got 7 over 2. Because square root of a fraction is the same as you take square root of 49 and square root of 4, right? So my equation here is reduced into x plus 5 over 2 equals to plus and minus 7 over 2. And so now what I'm going to do next, I'm going to subtract 5 over 2 to both sides. Okay, and my equation here would yield, this time my equation here would yield x equals minus 5 over 2 and plus and minus 7 over 2. Okay? And so now at this point, once again, I agree. If some of you are weak with fractions, you must go back and practice your fractions skill. But here, the x equals minus 5 over 2 plus and minus right here. It means, first of all, one solution is minus 5 over 2 plus 7 over 2. And that is going to give me 1. X equals 1. Okay? And my second solutions, x equals minus 5 over 2 minus 7 over 2. So it's going to be x equals minus 6. So that's my other solution to the equation. And this is where I'm done solving my quadratic equation. X squared plus 5x minus 6 equals 0. Okay? And last example on this topic here, we can try another, how about we try another example that involves some imaginary number, because once again we learn how to handle imaginary number, right? So let's look at example number 5. Still we are solving, right? And my equation this time is an x squared plus 4x plus a 13, and that equals 0. Okay? And once again, I want us here together to solve this quadratic equation here by completing the square. So, rewriting the equations, x squared plus 4x plus 13. Once again, first step, I want my last term right here, the c term, to go to the right side of the equation. So I'm going to have to subtract this time because it's a plus sign. So I'm going to subtract 13 to both sides. And what I'm going to have here, x squared plus 4x equals minus 13. Okay, everybody agree here? And then my next step, once again, at this point here, start looking for my b value. My b value here is a positive 4. Once again, the sign here is positive. So on a little side note right here, I have to do b over 2. I always want to find b over 2. Okay, b over 2 this time is a 4 over 2. Okay, which is 2. And the sign, once again, the sign is a positive sign. Okay, plus 2. So now, on my left side here, I can go ahead and turn that into a perfect square on my left side. To turn that into a perfect square, all I have to do is simply produce for myself a pair of parentheses with a square outside. And now what goes inside of that? An x. No square. And the b over 2, which is 2. That right there, the b over 2, goes right there. And what's the sign of b over 2? The plus sign. So I have x plus 2, all squared. And then on the right side, besides the minus 13 there, I need to add. Now my b over 2 quantity right here, I have to square it. 2 all squared. And I add that to my right side. Okay? So I have come up with my new equation right there. So my new equation here, to clean it up a little bit, it's going to look like x plus 2 all squared equals to minus 13. Now plus with 2 squared is a 4, isn't it? So I have x plus 2 all squared equals minus 9. Okay? Minus 9. So now once again, at this point right here, we can use the square root property. Because, yes, we can use the square root property. Because the point here is that we got a perfect square on the left side, and we have a number on the right side. So what I can do here, once again using the the square root property, we have x plus 2 on the right side, on the left side, without the square, okay, and equals to now plus or minus the square root of a negative 9, okay. And then now, since we have learned something about the imaginary number, right? The right side, we're taking the square root of a negative number. So now the right side has to be plus and minus 3i. If you don't remember how to do that imaginary number, you must go back and review our lecture notes on imaginary and complex numbers. Okay, so once again, the point is square root of negative 9 is a 3i. And so I have on the right side plus and minus 3i. Okay, and then the next step here, we solve for the x. Minus 2 to both sides. Okay, and so my solution here, x equals to minus 2 plus and minus 3i. So what does this mean? This means my solutions are going to be my first solution of the equation. X equals minus 2 plus 3i. That's one solution. My second solution, x equals minus 2 minus 3i. That's what the plus and minus notation means. Okay? So once again, now what you notice, this time, instead of having nice looking number, instead of having real values for the solution, we are having complex number for solution.